Let us make our own number patterns, and from here we will go on to describe what a sequence is. You can make your own number patterns using coins or matchsticks. Okay, let us see. Let us assume there is a package, a bag, okay, of size 1. Okay, in that pack 1 you got 1 coin inside. Size 2 you have 6 coins. Size 3 you have 15 coins. Assume this is a bag of having different sizes. Size 4 has 28 coins. What would be the number of coins that is required for size number 5? That is, how many coins you may need to have a bag of size 5. See what you are saying? Let us put this example in the matchsticks. Remember, you are going to sell a matchbox, okay? Pack 1, people who are going to pay very less may have very few matchsticks. Maybe I call it one stick inside, okay? That's, I call it size 1. In a size 2 pack, I will have 6 matchsticks. In that size 3, I have 15 matchsticks. If I decide to sell a size 4 matchbox, I may having 28 matchsticks inside. What would be if I give a big size, mega size matchbox called size 5? How many sticks should be inside there? Okay, like this. 1, 6, 15, 28, then what? That is the question, right? Let us find that out. It is not an easy one. Let us find how to find this number. This is called the sequence. The sequence, what is needed to add to this to find out how we can arrive at this number. Okay, we will go into these things. Numbers can have interesting patterns. Here we list the most common patterns and how they are made. From the previous examples, we will find out how that pattern works and how we have to come to a conclusion. Okay, let us take this sequence. 1, 4, 7, 10, 13, 16, 19, 22, 25. This sequence has a difference of 3 between each number. The pattern is continuing by adding 3 to the last number each time. Okay? Let us take another sequence here. 3, 8, 13, 18, 23, 28, 33, 38, etc. This has a difference of 5. 8, 3 plus 5, 8, 8 plus 5, 13, 18, 13 plus 5, 18, like this. Okay? Each number. Okay, let us find out then how this sequence, what is a sequence, okay, and how it works. Sequences and series. A sequence is a set of things, usually numbers, that are in order. The previous example, we saw a sequence of coins and the size, matchsticks and the size of the matchbox, right? Now here we will look at in numbers so that everything else will be a lot easier. 3, for example, take this sequence here, 3, 5, 7, 9, etc. Every digit is called a term, and 3 is the first term in the sequence. 5 is the second term in the sequence. 7 is the third term in the sequence. Fourth term is the 9. The 3 dot means goes on forever, infinite, and 12, it all goes on. Okay? You can call this as the first term, or you can call it as an element in a sequence or a member of a sequence. It all means the same. Don't get embroiled in the terminologies. So every matchstick or a coin or anything can be reduced to a sequence of numbers, so that we can solve for our answers for the future requirements. There are two types of sequence, infinite or finite. Let us find it out. If the sequence goes on forever, it is called an infinite sequence. Dot, 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 it goes on. Or if it just ends 3, 5, 7, that's it. That's a finite sequence. Let us see some examples. In the sequence 1, 2, 3, 4, dot, 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 dot. It's a very simple sequence. It's also called a natural number, right? Okay, but it's in a sequence. When you write it like this, it is called a sequence, and it is an infinite sequence. Simple infinite sequence. Here, let us take a second example. 20, 25, 30, 35, etc. is also an infinite sequence. It is a little bit little complicated because it has a different pattern. 1, 3, 5, 7 is the sequence of the first 4 odd numbers. You know, the first 4 odd numbers is 1, 3, 5, 7. It is a finite sequence. Look, it is not going on. You don't have that dot, dot, dot here. Okay. 4, 3, 2, 1 is 4 to 1 backwards. So, sequence going backwards. That's all. What is this sequence? 1, 2, 4, 8, 16, 32, dot, dot, dot is an infinite sequence where every term doubles. Look at here, 1, 2, 2 becomes 4, 4 becomes 4 into 2, 8, 8 becomes 16, 16 becomes 32. So it's an infinite sequence, goes on. Each term, what is this? Term, member, every member or every element doubles. This is a finite sequence, but this is an infinite sequence. We can have a sequence of letters where the members are A, B, C, D. This is a finite sequence of 5 letters alphabetically. Okay. F, R, E, D. This is a sequence of letters in the name Fred. Write your name. What is your name? Anil. If your name is Anil, how do you write it in a sequence? A, N, I, L. The alphabets. The sequence of alphabets used to create your name is finite sequence. In this, take another example. In this sequence 0, 1, 0, 1. This is an alternating sequence. It's a sequence of alternating zeros and ones, right? Yes, they are infinite. They are infinite alternating sequence. They are in order. And what is the order you are saying? 0 is alternating, right? And 1 is alternating forever. So, these are the different sequences. What we mean by that when we say the term in order? We said here it is in order. Even though it is repeating, there is some order we are seeing here, right? It is going backwards. There is some order here. 4 odd numbers. There is an order here. Look, there are orders. 20 plus 5, 25 plus 5, 30, 30 plus 5. There is some order in there. So what is, when we say the term order, they are in order, we are free to define what order that is. They could go forwards, backwards, or they could alternate, or any type of order you want. Okay? So look, a sequence is very much like a set, but with the terms in order. A set may not have things in order, but a sequence need to have things in elements in order. And the elements can appear any number of times, but there has to be an order, not a random one. So that's why the example is a sequence of alternating zeros and ones. The set would be just 0, 1. Right? If you have to represent this as a set, you will be representing this as 0, 1. But when it is a sequence, you can represent the set in a sequence like 0, 1, 0, 1, 0, 1. Right? So, if you want to go back to remind yourself what is a set,